So now let us look at data cleaning. Data cleaning as a process. Let us look at data cleaning as a process. So when we look at data cleaning as a process, generally people think data cleaning as a process which handles inaccurate data. So that is what is the general thought of as data cleaning as a process which handles inaccurate data. So what is inaccurate data? Missing values and noise. Okay, and inconsistencies are what are called as inaccurate data. But is data cleaning only a process which handles inaccurate data? No, actually, data cleaning is a much bigger job than handling inaccurate data. So, what is data cleaning going to be doing? What is the task that is going to be handled in data cleaning as a process? So, we'll be talking about now. We'll be discussing about how exactly do we proceed with tackling this task of data cleaning as a process, and then do we have any tools that are going to be used to handle this task of data cleaning? These are the discussions that we are going to have now. So now the first step that we're going to have in data cleaning is discrepancy detection. Discrepancy detection is the first and foremost activity that we're going to talk about in data cleaning. So what is discrepancy and how do we detect discrepancy is what is the first activity that we're going to do. So what are the factors? We're going to discuss about the different factors due to which discrepancies can be caused. So these are the following are the factors due to which discrepancies can be caused in the data. So number one, not always the people who fill in the data are going to be responsible for the discrepancies. The discrepancies can be caused due to poorly designed data entry forms that have many optional fields. So many optional fields are there and people can write anything in these optional fields. Therefore, that could be one reason for discrepancies in the data. Human errors in data entry can be one reason. Number three, deliberate errors. So somebody is going to force the customer to write their feedback form and he's very angry, and without filling in the feedback form they may not be generating the bill. So in such cases the customers are likely to do deliberate errors, and these deliberate errors are going to be caused because of frustration. Next, data decay. So they might be entering, and for example they might be entering an outdated address, so address which was used long back. So such addresses can be used, and that is what is called as decay of the data. Next is the inconsistent use of data representations and codes. So for example, in case we want to take the gender, of a person who comes into the shop, for example the mall. So sometimes what we are going to ask is we are going to give them options as male and female. Sometimes we ask them to write. Sometimes we ask them to fill in. Sometimes we ask them to choose the option. So these are all the different. So when we ask them to write, there are different possibilities of what they write. So when we give them options, they'll go to choose. So so that is the one sort of inconsistency that is going to happen in data representation and the codes that we use for representing the data. Next comes the errors in the devices that we use. So in devices that we want to take input, there might be errors in the devices that we take input from, the sensors that we use, okay, the biometric machines that we use. These all might be having some errors, and system errors in case of any errors in the system. These all can also be a reason for discrepancies in the data. And errors due to inconsistent use of data integration. For example, they were trying to integrate data from Excel sheet. The data from Excel sheet is integrated with data from SQL Server, and one more data from the text format is going to be integrated. All these things, if they are going to be integrated, then there are going to be some errors because of this data integration from various sources of data. So these all could be the factors due to which discrepancies are going to be caused. Now we'll talk about how we handle the process of discrepancy detection. So how do we start the discrepancy detection? So what we are going to do is to start with, we can use metadata. Metadata is data about data. So which means whatever knowledge we have about the data, that knowledge is going to be used to answer a few questions about the discrepancy. So the questions can be like this. So what are the domain and data types of each attribute? Depending on the domain and data type of each attribute, discrepancies that occur can be eliminated. What are acceptable values for each attribute? We are going to decide on what are the acceptable values that are possible for each attribute. Depending on the acceptable values, we are going to try to eliminate the discrepancies, or we are trying to detect the discrepancies. What is the range of the length of the value? What is the range of the length of the value? So how many bits are going to be used for the discrepancy, for the value, and how many bits are given? So this is the range of the value, is what is the next one. And do all the values fall within the expected range? So do all these values for example, we think range. For example, in case we are trying to use gender, because this is one common example. All these years we used to use only two genders. Now we are using three genders. So as a habit, if we are trying to use only one bit, we are trying to use one bit to say, when you say 0 can be a female, 1 can be a male, then the transgender, which is the third gender, may not fall into this category. So therefore we can, this is a problem where the values do not fall into the expected range. That is what is going to be the problem. And are there any known dependencies between the attributes? So do the attributes have any known dependencies between them? So in case there are dependencies, then we'll be able to detect the discrepancies that happen. So these are all a few questions that can be asked as in the point of view of the knowledge, from point of view of knowledge, as far as how discrepancies can be detected. Now, from the data analyst point of view, if two more things are to be examined. The first one is called as field overloading. Okay, for example, sometimes some attributes, for example, for an attribute we use 3 bits. 3 bits are used. So let us say only 2 bits are used. So there are going to be, though when 3 bits are used for the attribute, there are 8 possible values, as we all know. Let us say currently we are using only four possible values for this. So which means that one bit is left alone. 1 bit is not used. So in case the developers, what they're trying to squeeze new attribute definitions into the unused portions. Unused portions is this 1 bit. So this 1 bit is the unused portion. Into this, in case the developers are trying to squeeze in any new attributes, then this is what is going to be called as field overloading. This is what is field overloading. Next is the unique rule. So each value in the attribute must be unique from all the other values of the attribute. So this is something that we all know. So unique values are going to be required for all the values in the attribute. Next is the consecutive rule. There can be no missing values for the highest and the lowest values for the attributes. So no missing value so for example, we have a range from 0 to 5. And in case I don't use 3 in between, it won't make sense. I should be using all the values in the range, in the lowest and highest values. So that is what is consecutive rule. Next comes the null rule. The use of blanks, question marks, and special characters. Because there are going to be a few data elements where the people do not have an answer. For example, a person who doesn't have a driving license, if you ask the person to write his license number, they will not have an answer. So in such case, what to do? In such case, should he keep a blank? Should he put a question mark? Should he use a special character? In case he uses these question mark or blank or special character, how is this data going to be handled? These are all the issues that that people are going to look at as a data analyst. Now coming to the tools that are going to be used for discrepancy detection. There are a few tools that are going to be used to help in discrepancy detection. So number one is data scrubbing tools. These tools use simple domain knowledge to detect errors and make corrections in the errors. Depending on the domain knowledge, they are going to do the correction of the errors. Next comes the data auditing tools. These tools find discrepancies by analyzing the data to discover rules and relationships and detecting data that violate such conditions. They are going to formulate some rules and regulations depending on the analysis that they do on the data, and depending on that, they are going to check. These tools are going to check if any data violations are being done, and then they are going to handle. These are the two tools that we have for handling discrepancy detection of the data. Now coming to the second step. So the first step that we have discussed is data discrepancies that are going to be handled. Second step is going to be, once we understand the discrepancies, once we know the discrepancies, the second step is going to be data transformation. Data transformation is going to be the second step that we use in data cleaning as a process. So we have discussed already about data transformations while talking about data pre-processing. So data transformations can be simple or normalized, as we have discussed already. Simple data transformations and normalized or standardized data transformations. So these are the transformations that we are going to use. And there are a few tools to assist in data transformations. Number one is the data migration tools. Data migration tools. These tools allow simple transformations to be specified. For example, you can replace gender by text. So these type of activities can be done by data migration tools. Next comes the ETL tools, extraction, transformation, and loading tools. These tools allow users to specify transforms to a graphical user interface. So a graphical user interface is going to use, and because there are huge number of data that is available, and not only huge number of data, variant sources of data are going to be there. So because various sources of data are there, transformation is going to be required because all of them need to be on a common platform. So therefore, the users are, in the ETL tools, users are going to be given a graphical user interface where they are going to transform the data into a common. For example, the same case where you want to, so in some data locations gender is used, in some data locations sex is used. Okay, so both of them need to be consistent. Therefore, the ETL tools are going to use graphic user interface to specify the transforms that are going to happen. So this is the way in which data transformations are going to happen, and these are the tools that are used. So this two-step process of discrepancy detection and data transformation is actually an iterative process. The reason is, once we detect the discrepancies and then we go for data transformation, new discrepancies are going to be detected. New discrepancies can be added. Some transformations may introduce more discrepancies into the data. Okay, so that is one problem. And some nested discrepancies may also be detected. For example, the date. So when we see the date might be in different forms. For example, somebody says today's date. Today's date is 3/9/2020 is today's date. So somebody might write it as 9/3/2020. So this is what is the discrepancies in the data. So what we do is, for this type of data that we have, we put a common date format, and then we change all the dates into a common format. So for example, date followed by month followed by the year is going to be done. After we do this, all of them will be transformed. Once all the data is being transformed, then suddenly we might find a case where somebody has given one extra zero. Somebody has given an extra zero in the date column in between. Instead of it is 2020, now we find that that data is 2000 020, because this we don't expect in the beginning, so we don't look for this in the beginning. But once the data is, all the data is in the same format, then we can clearly observe this type of nested discrepancies that are going to be added. So such discrepancies are to be handled. So this is what is to be handled. So therefore, we need to find new approaches to data cleaning, and these approaches, they emphasize on more interaction between the discrepancy detection and data transformation. So generally, what we do is we finish the discrepancy detection completely, and then we go for data transformation. This is not the right way, because if you do it in this way, after the data transformation is again is finished, we might again get more discrepancies. So therefore, again, these have to be identified and detected, and then again we have to go for data. So what we are going to do is, at each stage of discrepancy detection, we are going to involve data transformation, and then we are going to check. So it is going to be more interactive. Both these phases need to be more interactive, and we are going to check each other, check whether discrepancies detection is done, and then we check it with transformations, and we're going to check if more discrepancies are there, and we're going to check if nested discrepancies have come in, and all this checking is going to happen, and then we go for the next step, discrepancy detection. So this is the way in which we are going to handle the process of discrepancies. So with this, I stop the lecture.